Okay, so the first question, as before, right? So this is page. Can you remind me, please? This is question 7, and what is the page?
This is page 145.
145.
145. Yes, 145. Okay. So my question is, what is the first step of the algorithm?
We
We
check
can
if
determine
the size
what we need to optimize.
So what do we need to optimize here?
the perimeter.
The area.
The area.
Perimeter
Why perimeter? Look,
Okay.
it says maximum of the enclosed area, right? So we are optimizing the area. Now let's clarify. What is the enclosed area? Is this, for example, how can you describe the enclosed area on this diagram? Where is it? If it's enclosed area.
The area in between the area in between the lines.
So both rectangles, right? So you understand
Yeah,
that enclosed area is all of this. So basically you can say also that it's a bigger rectangle, right?
Mm-hmm.
So that's the area, okay? So in this question, to make it easier for you, the textbook has already offered variables, okay? So since we are optimizing the area of the big rectangle, I'll write it like this, big rectangle, okay? So we are looking for its maximum, right? So we need to move on to the second step. What's the second step?
We model an equation.
We model an equation.
The
Right. So we need to model the equation of the area. So the area of this shape, right? So what is the area of this shape formula?
Length times width.
Length times width. Okay. So now, since we have this already diagram provided, you can right away replace the length and width with the suggested variables. So what is the length of the big rectangle? 2x.
2x.
What is the times? What is the width of the big rectangle?
Y.
It's y. Okay. And basically, after this question, well, after this line, you can ask yourself, did we finalize modeling the area or not? Is this the final equation for the area? Just tell me yes or no, your suggestions, don't be silent. Huh?
Yeah. Or would it be minus
You didn't
y?
answer my question.
Because
my question is, did we
yes.
finalize the equation for the area? Yes?
No.
No. What is the obstacle? What's the problem?
We have two variables.
We have two variables. So any function that we model has to be in one variable, right? Has to be in one only variable, right? We in this course we don't know how to solve anything with two variables. Okay, so then it means that one of these variables have to be expressed in terms of the other one, right? So here comes the rest of the question. So let's agree on what? Let's agree to express y in terms of x, right? So let's express y in terms of x. Okay, so what other feature of the rectangle is linking the variables x and y?
The perimeter.
The perimeter. What do we know about the perimeter of this enclosed area? Now, given that we have this, right, side as well. So when you are fencing, right, you're fencing all of them, right? So how can we express the perimeter to represent all the sides as a sum of all the sides. So generally, the simple definition of a perimeter is a sum of all sides, is a sum of all sides lengths. This is a simple definition of a perimeter. Perimeter is the sum of all a sum of all sides lengths. Sides lengths. Okay, so I want an expression of the perimeter based on this definition for this shape. Abdurrahman, what?
I have to make it a simplified form.
But not factoring. But simplified, if you can expand and collect like terms, then yes. Okay, anybody?
I was guessing it would be 4x plus 3y.
4x plus 3y, absolutely. So this is x, and this is x, and this is y, and this is y. So basically, the perimeter is a sum of all those sides, right? So it's going to be 4x plus 3y. So do we know the length of the fence available?
That's 1,000 meters.
It's 1,000. So we know that perimeter equals 1,000 meters. So it makes it means that the next line, Nada, will be next division line.
1,000 equals 4x plus 3y.
4x plus 3y. And now it's time to think, to remember, why am I doing all of that? What am
Because
I
I
going
want
to...
the dimensions.
No, not because of that. Guys, why I'm doing this?
Because you need to express y in terms of x.
Absolutely, we are doing this because of that. You see how easily to get lost in all those steps. You have to always remind yourself, why am I doing this? What is my target? So would you not be able to express y from this equation in terms of x? Basically, isolate y, right?
Yes. So 1,000 minus 4x over 3 equals y.
Over 3 equals y, absolutely. Guys, do you have any questions about it?
No.
And basically, I don't see the reason to simplify this, right? Because 1,000 divided by 3 will not be an even a whole number, and 4 divided by 3 will not be a whole number. So let's keep it as is. So now, again, what should be the culmination of the second step? Ziad, what should be the culmination of the second step?
Area
Area is an expression, right? In one variable, as a function in one variable. So tell me now the final equation for this function. So
area equals 2x times
2x times
1,000 minus 4x over 3.
Okay. Now we also can make this function. So the function is ready, right, for us to work with. However, since we are mindful of the next step is derivative. So we want to rearrange the function in a way that it's convenient for us to differentiate. So with this in mind, Omar Fuad, what do you have to offer?
I think we would make it 1,000. No.
Is what?
Maybe I was gonna say 2x multiplied by.
Guys, one at a point. So one at a time. Right now, Omar is talking again.
I was gonna say put the 3 at the top. Maybe make it a negative expression.
You're making it harder. Ziad, what did you have to?
We cross multiply.
No. You cross multiply.
Miss, we're going to.
Just a second. Ziad, when do we cross multiply? When you have an equation. Something like a value on the left and value on the right. In this case, you have a letter on the left to cross multiply.
Miss Natalia, we're going to, since 2x is over 1, so we're going to put 2x in the numerator.
Absolutely. But I also want to offer something. You know that whenever you have a constant, you can take it out of the derivative sign, right? So I can write this 2 over 3 separately. This will be my constant multiple, constant coefficient, right? And then, as you said, Nada, x will go to this.
So it's going to be 1000x minus 4x squared.
Here up 1000x minus 4x squared. Okay?
Yes.
Over 3. Guys, Ziad, Omar, are you fine with that?
Yes.
Or Ziad? Ziad. See here?
Yes, I'm trying to get the hang of it.
If you have a question, ask.
يعني look
Okay.
at I'm trying to get the hang of it.
What does this mean? Should I move on?
يعني yeah, move on. You must move on.
Okay. So 3. Third step, please. Follow the algorithm. Zia, do you remember the third step?
Yes, we need to find the derivative.
Okay. So at the third step, we're going to differentiate the function a prime a prime of x, right? Because our function is a of x. I will add it here, a of x. For the consistency, okay, for the sake of consistency. So when I'm going to, I will show you once again, why did I take this 2 over 3 out? So 2 over 3 times 1000 x minus 4x squared prime, right? So when I find the derivative of this is a constant, a coefficient, so I can take it just out. It will be 2 over 3, and then this needs to be differentiated. And this is easy because you don't have any kind of composite functions or product rule or whatever. So who would like to tell me the derivative?
The derivative would be 1000 minus 8x.
Yeah, so 2 over 3
1000 minus
times 1000 minus 8x. Okay? And that's it. You see, it's a factored form. I mean, there is a product, there's a coefficient and the bracket. And you remember that is the best one. Why?
Miss Natalia,
Yeah.
I have a question. Why did we take the 2 over 3 out?
Because according to the derivative rule, when you're multiplying, for example, look, for example, if you are differentiating 3x, what does it actually mean? That you take 3 out of the derivative sign, and then you differentiate only x. You remember that was the first rule, which we took in the derivatives. So the derivative of x is what?
It's 1.
1. So it becomes 3 times 1, which is 3.
Oh, okay.
So whenever I can, yeah, it will make my calculations easier. So whenever I have a coefficient, why is the coefficient? Do you see here where I'm pointing? Because it's a product. So whatever constants which I can multiply and take them out as coefficients, I should go for it because it makes my calculations easier.
Okay.
Okay, so what else do we need to do at the third step, Ziad?
We need to find the zeros of the derivative function.
Yeah, absolutely. So we take 2 over 3, 1000 minus 8x, and equate it to 0. What can you say about solutions, how to solve this equation?
Yes, we isolate for we move the 2 over, we distribute, we can?
I just mentioned that if a product is equal to 0, this is the best possible scenario. Because if the product equals to 0, then you can take each part of the product and equate it to 0 separately, which will make your equation smaller and nicer. So 2 over 3...
1000 minus 8x equals 0? 2 over 3.
Absolutely. No, 2 over 3 cannot be equal to 0 because it's a constant, right?
Because it's a constant, yes.
So you can disregard it. Yeah.
Yes, minus 8x equals 0.
Yeah.
We'll move the 8x to the other side.
No, I moved the 1000. Anyways, so what is the x value?
Divided by x equals negative 1000 over 8.
Yeah, which is
125,
probably.
125.
No? Yeah.
That's 125.
125. What are we looking for? Are we looking for the dimensions? 145.
Yes.
we're looking for
Just
the
a second.
dimension.
It says what dimensions will maximize the enclosed area. I just want to make sure that this is the answer for X. Just a second. 145.7. Before we move on, I hope that you can see that our algorithm is not complete yet. 145
We
question.
still need to get the Y. Determine.
Not only this. This is about. It's too early to think about why. Think about it. Yes, it's correct. Okay. So before we start thinking about why, we have not.
We need to sub this. We need to sub
Of
this
the zeros in
into
the
the
derivative
original.
function.
Absolutely.
Of the
Yeah.
zeros of the derivative in f of x.
I mean, in the derivative.
Okay, but is the zero of the derivative the only thing we should sub into the?
No, and the zeros of the first
No, we
function.
need to.
No, not the zeros of the first function. No, guys, check the fourth interval. Well,
We need to
already
sub in
answered.
the endpoint.
Endpoints, and to have the endpoints, you have to determine the interval.
Yeah, we need the domain and the intervals.
Yes, and so we didn't think about interval yet. Okay, so the fourth step is always thinking about interval. But I want to tell you that in some of the questions which are in this bonus list, do not have information about intervals. So then, in this case, like Mo, for example, he came to me today to ask something. So he did. So in this case, you will have to use graphing technology. But let's see if here you can. If here you can do it or not. Let's see. Just a second. I will first. You finished? Give me the paper. Just a second. So I want to think about interval. Please look at the function, and this is our function, right? This is the function. And tell me, how should we start thinking about the interval? 1 minute until I answer the question here. Marwan.
Number 5. After that, the equation one sketch, then the derivative.
No equation. You just sketch the derivative on top of that graph directly.
The calculated equation.
You don't need equation for this question. There is no equation. Okay, so guys, interval. So any ideas?
Yes. We from the original equation for the area, we equate 2x or 2x is bigger or equal to 0, and then 1000 minus 4x over 3 is bigger or equal to 0.
So x has to be greater than or equal to 0. This is clear. Let's see if this other expression of the width will give us any information or not. It might not. Then I will show you how to use the graphing technology. So this has to be greater than 0. That means that 1000, right, minus 4x has to be greater or equal to 0. So let's try to solve this inequality.
It's 250.
250.
It's already, x has to be greater or less?
X has to be less.
Less than 250.
You see that, right? I don't need to do the, okay, I'll do like this for
Yes.
negative 1000. So after that, x is less than 250. Perfect. So you see that this information provided us with the interval. Okay. So what is the interval?
Yes, I have a question.
Just a second. What is the interval?
0 and 250.
From 0 until 250. Yes, Ziad.
Why did we remove the 3?
Okay. We are to decide if this fraction is positive or not, right?
Yes.
Ziad. So 3 is 3 positive or not?
Positive.
3 is positive. It means that 3 does not have any role. So as long as the numerator is positive, then the whole fraction will definitely be positive. Okay? That's why we can disregard it. Yes, because the constants, they don't change anything. Okay. So,
Miss, and can I ask another question?
yes, Ziad.
What is the importance of the 2x is greater than 0 on?
Okay, the importance is a lower bound. Like interval has got always upper bound and lower bound, right? I don't know what's this sound. Got it? Okay. So, Omar, what's your question?
For the thing on the right, for the fraction with 3 at the bottom, can't we just think of it as multiplying both sides by 3 to cancel out.
You
the
don't have both sides. You don't have an equation. Do you see that on the left, you have nothing. You have just a letter, a function notation. You can do this if you have numbers equal to numbers, right?
No, I meant for the interval.
Are you talking about, okay, yes, possible as well, yes, of course. You can multiply both sides by 3, yes.
Okay.
Okay, so now we have the interval. What are we doing at the next step?
We sub in the endpoint
Okay, we need to list
in f of x.
all the values of x, which we are going to substitute into the original function. So tell me, what are the values? Nada.
0,
1.
0, 125, and 250.
Yeah. Okay, and sometimes, like today in the lesson, the derivative 0, the 0 of the derivative, might be outside the interval, right? Then you drop it, because you are to work only on the interval. So in this case, the derivative, there is only 1 0, and it is inside the interval. Okay, so let's sub it in, guys. Quickly, let's calculators, please. Well, for 0, it's clear, right? Because it's a product. So for a of 0, of course, will be 0. For a of 125, it's also clear, right? Why? You see that? If I multiply 125 by 4, no, it's not clear. It's not clear. So for 125, you have to sub it in. For 250, it's clear.
That's for 250, it's 0.
Yes. So you need to only check 125. Who is subbing into the equation?
I am.
Yes, Omar, please.
I'm doing it right now. So.
I got 41,666.
What did you get?
41,666.66.
666?
41,666.
Ziad, you got something similar?
I got the same thing.
Okay, good. So guys, okay, and then we compare, right? Choose the maximum. This is easy, but don't think that it will be always like this. So sometimes the endpoints will give you the values other than zeros. Okay, so that's why you have to do it every time until the next unit, because in the next unit we will look into another tool which will make this algorithm shorter. So you will not need an endpoint anymore. Endpoints. So choose the maximum. Now, so we know that the maximum area is this one, right? So this is the maximum area. And we know that the x dimension is 125. So what is left?
The y, the width.
So we need to find y. Okay, so how can we find y?
We can sub in 120. So we're going to sub in 125 in the original.
And 4,166 in the original. Okay,
Where?
sorry, Nada.
Where?
No, it's not. We know that the area is.
Didn't we say that this is y, guys? We said that this is y. So we can just sub it into this expression.
Yes, we're gonna sub x into this one.
So it's gonna be 1,000 and then minus what? 4 times 125 over
500.
over 3?
No.
Yes.
Over 3. Okay, so could you please calculate and let me know?
It's 166.67.
166?
0.67.
26 or 66?
166.67.
Okay. 166.67. Okay, and this is all in meters. Yeah. So this is the meters, and then we can say that the dimensions of 125 meters by 166.67 meters will give us the maximum area of 41. We don't have to say of which area. They just ask us which dimensions will give us the maximum area. So they want only this and this in the final statement, okay?
Okay.